Chemical calculations. The most important thing with chemical calculations or stoichiometry is to start with a balanced chemical equation. So make sure it is balanced before you start. We'll look at this example here. Now, three what are called mole ratios can be derived from this equation based on the coefficients. If I want to convert from KClO3 to KCl, here is my mole to mole ratio, and that would allow me to switch from KClO3 to KCl. Another mole ratio, if I want to go from KClO3 to oxygen, it's 2 moles of KClO3 for every 3 moles of oxygen based on the coefficients. And then finally, I can go from KCl to oxygen based on the coefficients from the balanced chemical equation. So these mole ratios allow me to convert between different substances. So let's look first of all at mole to mole calculations. How many moles of aluminum are needed to form 3.7 moles of Al2O3? So we have 3.7 moles over here. I want to know how many moles of aluminum I need. I'm going to start with the number I'm given, so 3.7 moles. Write your units, Al2O3. Since I'm already in moles, I can go from moles of aluminum oxide back to what I'm looking for, which is aluminum. And this is the step where I use the coefficients from the balanced chemical equation. So go back to your balanced equation. There are 4 moles of aluminum for every 2 moles of Al2O3. Moles of Al2O3 cancel out, and I've got moles of aluminum. So then it's just a matter of multiplying 3.7 times 4, dividing by 2, and so this would require 7.4 moles of aluminum. Let's look at one more example on a mole-to-mole calculation. We have 0.78 moles of oxygen. And I want to know how many moles of aluminum oxide are formed. So start with 0.78. We're already in moles, so we can do our mole to mole ratio. We're trying to go from oxygen back to what I'm looking for is Al2O3. This is where we use the coefficients. Go back to your balanced chemical equation. We're looking at oxygen and Al2O3, so my coefficients are 2 to 3. Moles of oxygen cancel out, and I will get moles of aluminum oxide. So 0.78 times 2, then divide by 3. So I would form 0.52 moles of aluminum oxide. If we don't start in moles, if we start in mass, the mass must first be converted to moles by using the molar mass, and then we can use the mole ratio. So let's look at this example here. It's called a mass-to-mass calculation. I have 5 grams of CaC2. I want to know how many grams of acetylene. So it's mass to mass. Well, I'm going to start with the 5 grams. Always start with the number you're given, CaC2. If I'm in grams, though, first I need to go back to moles. So I need the molar mass of CaC2. For every 1 mole, go back to the periodic table, add up calcium, which is 40.1, and then you got 2 carbons, which are 12 apiece. So that's 64.1 grams of CaC2 per mole. That'll cancel grams. Now I've got moles of CaC2 down here. And this is where I convert between units. I'm in moles. I'm going to do my mole-to-mole ratio. Balanced chemical equation. It is balanced, and it is 1 to 1. So that will cancel moles of CaC2. I want to go to grams, so I need to add one more step here. Now I need the molar mass of C2H2. So there's 2 carbons, that's 2 times 12 is 24, plus 2 hydrogen is 26 grams per mole. That will cancel the moles and leave me with mass. So the mass of C2H2, when you do the math, 5 divided by 64.1 and then multiply by 26, 2.03 grams of the C2H2. Another example with the same chemical equation. I am starting with 49 grams of water. I want to know how many moles of CaC2. And again, if you write the stuff underneath the problem, it kind of helps to determine where you're trying to go. Well, I'm going to start with 49 grams of water. If I'm in grams, I first have to go back to moles. So we're going to go grams to moles using the molar mass. Molar mass in this case of water, which is 18 from the periodic table. That will cancel grams. I have moles of water down here. I want to go to moles of, I'm looking for CaC2. So go back to your balanced chemical equation. It's 1 mole of CaC2 for every 2 moles of water. In this case, I can stop here because I'm looking for moles. I'm already in moles. I don't need to add another step. So 49 divided by 18 divided by 2. The moles of calcium carbide, (1.36 moles of CaC2. So these are stoichiometric problems going from moles to moles or grams to moles. We can have other stoichiometric calculations as well, but the given quantity must first be converted to moles. There are some other conversion factors that we've used before. 1 mole is equal to 6.02 times 10 to the 23rd representative particles. So that could be 6.02 times 10 to the 23rd atoms, or molecules, or formula units. And then 1 mole of any gas occupies 22.4 liters at standard temperature and pressure. So these are some other stoichiometric conversions that we can use.